So it's time for circles, guys. We're going to first start with central and inscribed angles of circles. Let's see here. When you're done today, you're going to be able to describe the relationships between central and inscribed angles of circles, and you're going to be able to solve for those angles as well as something called the arcs that they intercept. So for vocabulary, if you don't have these circles printed in your notes, please make sure you draw a couple circles, and let's get some words out of the way and some formulas. Some you know. Circumference, let's just make sure we write some of the things we know about that. One version of circumference is 2 pi times the radius, or pi times the diameter. That's your circumference formula. Let's remember what what the diameter and radius is. On this first circle, let's label the center C, and let's put a point A on the circle, and let's draw a diameter. Whoops, I missed my center. We'll pretend we hit that. And so an example of a diameter here would be the segment AB. So that's a diameter. An example of a radius would be from A to C or from B to C. I'll just write AC. And then let's talk about semicircles and these things called arcs. Most of you know that semicircle goes halfway around the circle. So on this one we've drawn, that would mean from A to B. And now that's what an arc is. This word arc talks about a section of the circle as if it's part of the circumference, a section of the circumference of the circle. So let's go down here to this next one. Let's put some of the same letters on here. We won't draw in a diameter this time, but we can still put A and B in there. Let's put another letter D right here. And so what you have going on are arcs, or any of those cut out sections of the circle. A major arc is the longer way around. A minor arc is the shorter way around between 2 points. I'll explain what we're talking about. A minor arc would be, for instance, this section right here, and you could call it arc AD. You use a little curvy symbol over that, and that means from A to D on the circle. A major arc could also go from A to D, but it would go the long way around from A to D. So to name a major arc, you need 3 points to show that you're going the longer way around. So you might name that major arc A, B, D. You need all 3 points with the curve over it. We have central and inscribed angles. There's a little picture down here to the left, but let me just tell you about those. A central angle is an angle whose vertex is on the center of the circle. An inscribed angle, I'm not even going to take the time to write all that out right there. An inscribed angle is an angle whose vertex point is on the circle. Vertex is on the circle, not in it, is on the actual outside edge of the circle. Inscribed does mean inside, but that means that the angle itself is inside of the circle. Now this information right here that's really tiny, that describes the relationship between central and inscribed angles. So we'll look at that more just as we hit our examples on the next page. Here we go, example 1. Let me go ahead and tell you now about central and inscribed angles. Hopefully you read that back there under the vocabulary. But a central angle is the same measure as the arc that it intercepts. And intercepts means that it cuts into it. It intersects a section of the circle. So a central angle is the same as the, I'll write intercepted arc. We won't write intercepted every time. And an inscribed angle, which we'll see in the next couple of examples, is half of its intercepted arc. So what we've got going on here in the first picture is really simple. If this is 100 degrees, and colors do help you, like drawing out sections of the circle. If that's 100 degrees, then this question mark angle is the central angle because it comes out of the center. That intercepts, it slices out that piece of the circle like a piece of pie. And so that means that the question mark angle is also 100 degrees. And you're done there. But just to get you thinking, for this next picture, if this is 100 degrees and this is the 155, sorry, my 100 didn't turn out too good there, you would have a way to find out this third section, because you should know something about a total angle adding up to 360. Okay, let's look at the second picture here. Remember, central angles are the same as their intercepted arc. So, if we have a 134 listed right here, then that means the arc from G to H is 134 degrees. We don't need that to answer the question asked for. Well, actually we do. So let's just talk our way around it. If we have 110 degrees, then that means from I to H is 110 degrees as an arc. And we already have the 75, but if you want to be thinking of everything going on here, you could also put a 75 degrees right there. And most of you hopefully are already thinking, okay, we need the entire circle to be 360, so that's all we're after there. We've got 75, we've got 134, and we've got 110 degrees of the circle. That leaves 360 minus 319 to be however much arc IJ would be. I believe my math is correct, so that's 41 degrees. So 41 degrees would complete the circle. Okay, for example 2, we're going to look at inscribed angles. I've already written here, and you should add that to yours. Inscribed angles, they end up equaling half of the arc that they intercept. So remember, to be inscribed, the vertex of the angle has to be sitting on the circle. So all of these angles you see in these pictures are inscribed. So let's find question mark angle right here. And here's the best way to do it. Use some colors if it helps you. Pretend you're rolling like a pizza cutter out when you make that angle. And that's what you slice out of the circle. So you slice out that arc right there. And if the arc is 130 degrees, an inscribed angle is half of the arc. So the question mark angle is 1/2 of 130. So the question mark angle is 65 degrees. And you're done. Second picture. The inscribed angle, which is listed as 47 degrees, if you roll a pizza cutter out right there, then you intercept this arc, which they've labeled with a question mark. So the inscribed angle is half of the arc. Should have called that an X, but I'll leave it a question mark. Or I should have called it arc CB. So if it's half of the arc, then we can double the 47 and get the arc length. So the measure of arc CB, the little m is just notation to say measure, would be 47 times 2, 94 degrees. Little circle humor there. All right, let's move on to example 3. This is just, it can get a little more complicated, and so you want to cut and slice out your picture with the arcs and the angles as much as you can. And then the other thing to remember is centrals are the same as their arc, inscribed are half of their arc. So in this picture, we've got to find A degrees, B degrees, and C degrees. So the first thing we want to do is I'm going to pizza cutter out again, angle A degrees. Comes from this angle right here, and it slices out that 70-degree arc. So A degrees would be half of the 70, so it would be 35 degrees. Got that taken care of. I don't think I can write small enough to write a 35 in there. Let's look at angle B. We'll switch colors. Angle B degrees slices right there. And of course you can tell already the pictures can get messy. So that sliced this 104-degree arc out. So the B degrees should be half of 104 degrees. So it should be 52 degrees. All right, so everything seems simple so far. Now, that angle C, I've drawn all over everything. So we're going to look carefully. We're going to trace this triangle right here. I'm going to try to make it look halfway like that was. The A degrees was 35. The B degrees was 52. And then if we could find this right here, that's an X. based on just the triangle information, then as you can tell, the C degrees is a vertical angle to that one in the triangle. So even though my picture is kind of messy, I hope that makes sense to you. So if we can find x by going 52 plus 35 and taking that off of 180, because that adds up to be the whole triangle, we'll have 93 degrees right there for the x. Now in that triangle, if this is 93, C degrees is also 93 because they are vertical angles. So you use all the math you know to work with these things. Let's look at example 4. They're going to throw in just a little bit of algebra here. So the first thing I want you to notice, though, is what's going on in the circle. Measure of angle BAC, that would be the central angle right there, and the measure of angle BDC would be the inscribed angle right there. Notice they both, watch this, here's the blue one, BDC, here's the red one, BAC, and notice they both intercept or cut out the same arc from B to C. So if we were to know what arc BC was, like 100 degrees or something, that would be easy, but it's algebra, so we're just going to talk about the relationship. 7x minus 7 would equal this same arc because that's a central angle, and the blue one should be half of that. So if we want to, there's two ways you could write this. You could say 7x minus 7, and if we'll take half of that, that should be the inscribed angle. Now you can certainly do the math that way because I think you can handle a 1/2, but this might be easier. If you can half the 7x minus 7 to get x plus 14, then you ought to be able to double the x plus 14 to equal the 7x minus 7. Just throw in some real numbers instead of the algebra to make sure that makes sense to you. All right, let's complete that algebra right here. I'm going to do it quickly. All right, I've got it going. Let's move our 2x. Let's move our 7. I'm going to show all this at once. And you should have the x equals 7. Lots of 7s going on in this problem. Now let's check our work because we have to find the actual measures of angle BAC and BDC anyway. So if we go 7x minus 7 and plug in a 7, you should get 42 for that one. Oops, that's actually the red one. I should have written that in red. So that is the measure of angle BAC. And then the measure of angle BDC is x plus 14. So 7 plus 14 would be 21 degrees. And you can take these two pieces of information and double check yourself. The blue one was the inscribed angle. The red one was the central angle. So if the central angle was 42, that means this arc was 42 degrees. And then half of that would be 21 degrees for the inscribed blue angle. Okay, it can certainly start looking messy when you draw all over the pictures, but do make sure you're drawing. Different colors will help you. And just, you have two things to remember. Central angles are the same as their arcs. Inscribed angles are half the measure of their arcs that they intercept. Good luck.